Hi. In this video, we will talk about derivatives and product rules. We're going to have a couple examples, including trig functions, logarithms, and natural log, and all that good stuff. So here we go. The first example I have x times tangent of x. So let's just say these two functions are multiplying. That's why I'm doing the product rule. So let's call this is going to be f of x, and this is going to be g of x. So the derivative of the f function, the derivative of x is 1, and then the derivative of tangent is secant squared. Okay, so now remember the product rule is, I'm going to write it right here on the side. It's f prime times g plus f g prime. Okay, that's the simple one. Okay, off we go. So f prime 1 times g is just tangent of x plus f times g prime. So f is x, g prime is secant squared. So this is the main idea. Now we just need to simplify and write the final answer fully factored and in terms of sine and cosine. So I also know tangent is sine of x over cosine of x. And I also know secant is 1 over cosine. So over cosine squared because it's secant squared. You can leave your answer like this, or you can find the common denominator between cosine and cosine squared. This is fully simplified already. Okay, so this will give you full credit. But if you want to go a little bit further, you can just write them both under one common denominator. So cosine squared will be the common denominator. Then you just need to fix the numerator. So that will be sine times cosine, and then plus x. This one doesn't change because this was the original denominator to begin with. So this one or this one. Another one. Let's go with h of x, so x cubed times e to the power of x. Let's say that this is f and this is g. So f prime will be, we're going to use the power rule right here to find the derivative of the x cubed. So 3 goes in the front multiplying, and then you subtract 1 from the exponent right there, making that 2. The derivative of e to the power of x is just e to the power of x. Now let's go ahead and apply the formula. So f prime right there times g right there plus f right there times g prime. Okay, this is how you set it up. Now we're going to factor. So we will factor out e to the power of x and also x squared. So e to the power of x and then x squared will be factored out. So I have 3 left over between all of this plus x right there. So this is my final answer, fully factored. Now the next one, let's throw some natural log in it. So for example 3, we have h of x with x to the 4th power times natural log of x. So let's say this is f, this is g, f prime, just like what we did in example 2. Power rule, so 4 goes in the front multiplying, and then you drop 1 from the exponent, make that 3. And then the derivative of natural log is just 1 over x. So the derivative of h of x is f prime times g. So f prime 4x cubed times g, so natural log of x, plus x to the fourth power, so f g prime. So x to the fourth power divided by x, or 1 over x. Okay, so we need to simplify this. So we will apply the rule when you're dividing and subtract exponents, so you have an invisible 1 right there. This makes x cubed. So let's go ahead and factor it out. So they both have x cubed in common and nothing else. So x cubed, so I have 4 natural log of x plus 1. Oh, I didn't need the big parentheses right there. Okay, because x cubed divided by x cubed is 1. This is your answer, fully simplified. Let's do one with log base 4. Because when you're finding the derivative of log with a different base, that might get a little crazy. So example 4. So let's say we have x squared times log base 4 of x. So f and g. So f prime, we already know, to x. Now g prime, the derivative of this is going to be 1 over x, the natural log of the base. So 4. That's not 41. Those are parentheses right there. Okay, so h prime of x, I have f prime times g plus f g prime. So we need to simplify here. That will leave us with only x. So now we just need to simplify. Oh, let's factor out x, leaving us with 2 log base 4 of x, plus I have 1 left over on top, because x divided by x is 1 over natural log of 4. This is fully simplified. Let's do one more with a trig function, because trig functions usually get everybody. So h of x, e to the power of 4x times cotangent of x. How about that? So f and g, f prime. So 4 goes in the front, multiplying. So that'll be k from a couple videos ago. So 4, and then e to the power of 4x, and then g prime. The derivative of cotangent is negative cosecant squared. So f prime g, so f prime is 4e to the power of 4x times g, so cotangent of x. It would be plus, but because this cosecant is negative, I'm just going to write negative right there. F g prime, so e for x cosecant squared of x. All right. So in the next step, I'll go ahead and rewrite the cotangent and the cosecant in terms of sine and cosine. and then I'll factor on the next step. So cotangent is cosine over sine, and cosecant is 1 over sine. Because it's squared, it's going to be sine squared. Okay. We can factor out e to the power of 4x, leaving us with 4 cosine of x over sine of x minus e to the 4th power divided by e is just 1. So I have 1 over sine squared of x. Now, this is fully simplified. This will give you full credit. If you want to go one step further and make this the common denominator of sine squared, it will look prettier, so why not? But you don't have to. So sine squared of x, we need to make this sine squared. So your numerator will be cosine x sine x minus 1, because this one doesn't change. That was the original denominator to begin with. This will also give you full credit. As you keep working on this, you'll be able to skip a couple steps or factor and change that in terms of sine and cosine all at once.